Hey guys, welcome back. So in this video, we're going to talk about how we can implement quicksort in Python. In the last video, we talked about the concept behind quicksort. So if you guys want to see that video or you don't know what quicksort is, definitely check that out. But a quick summary is basically what we want to do is if we're given an unsorted array, we want to keep partitioning our array in a way so that if our last number is the pivot, we want to make sure that all the numbers on the left side are going to be smaller than our pivot, and all the numbers on our right side are going to be larger than our pivot. And so in order to do that, we're going to be essentially making two functions. One function we're going to call split, and the split function is going to handle the partitioning of our numbers and bubbling our smaller numbers than the pivot on the left side and our bigger numbers than the pivot on the right side. And we're going to then recursively call quicksort on both halves of the array. And so what I'm going to do is I already have this array. I'm going to go over quick. I'm going to kind of use this as a quick example. So if we're just starting off with this array, we have 7, 4, 6, 3, and then I'm going to draw a line and 5. And so what this is saying is we're given this array, and we're going to use our last number as the pivot. And so in this case, our 5 is the pivot. And what we want to do is we want to make sure this 7 is basically at the very end. We want this array to look like this. We want either the 3 or 4. It doesn't really matter. It could be 4 or 3. We want our 3 and 4 here, and our 6 or 7, or 6 or 7, or it could be 7 and 6 on the right side, and then we want to insert our 5 over here. So that in this case, we know that our 3 and 4, all the numbers to the left of the 5, in this case 3 and 4, are smaller than 5, and on the right side, they're bigger than 5. And that's basically what the split function is going to hold or take care of. And obviously, quicksort, like I just said, is going to call on the quicksort equation recursively. So we do it on the left side and the right halves. And so once we've done it here, we want to call quicksort on this half and quicksort on this half, so that in this way we keep placing our numbers in the right positions. And so without further ado, I'm gonna just start working on it. Right now I'll put pass, or actually we'll start over here. So the quicksort function, the actual quicksort function, will take three parameters: the array itself, the start, and the end. And so if the start is if the start is less than the end, then we want to run our function, because if start is equal to or greater than end, that means we basically only have one number in the array that's given. And so we want to make sure that there's at least two, and we do that by checking if start is less than end. And then what we want to do, we want to call split on our array, on our start and our end. And so what this is going to do is we're just going to run the split method that we make, and this is going to return an index. I'll call it IDX for index. And what this index is going to be, it's going to be the index of this number that we put in the right place. And so using this, we can just recursively call our quicksort method on the same array, except we can do I plus 1 towards the end, and then we can do quicksort from our start to our I minus 1. And so this is how we can, these are just giving errors because we haven't handled further, not IDX, because we haven't created a function yet. But the concept in this is going to be, once we return this index, we know this index is in the right, this number is in the right place because all the numbers after are higher and all the numbers before are lower. And so when we return that index, we can just go from the start to our I minus 1, so that we do the left side of the array, and from our I plus 1 to the end of our array, which is going to handle the right side of our array. And so that is going to be the gist of our actual quicksort function. Now we can start working on our split function. So in our split function, what we're going to have is we're going to have obviously an array, a start, and an end. And we want to establish a few things before we continue. First thing I'm going to establish is I'm going to say I is equal to start, and our pivot is going to be equal to our A of end. And so what this is going to do is, if we're looking at this example here, A of end is the very last index. So in this case, we would establish our 5 as our pivot. And what we're going to say is we're going to use the idea that if we're going to loop through every number, and if this number, in this case 7 is greater than 5, so we're not going to do anything. But we get to 4, since 4 is less than 5, we want to swap this index with the index I. And so in this case, our index I is going to be over here. And the reason we're doing that is because once we do that, if let me change that. If we do that, we're going to have 4, 7, 6, 3, and then we're going to have the 5. And so what this is doing is if we swap it, we know now that since this was our previous I, we can increment I, and we know that now our number 4 is placed in the right position, is before the I. And so we know that now that number is definitely less than the pivot, so it's placed on the right, it's bubbled into the right place. And so I think it'll make more sense once we start coding it first. And so I'm going to code it, and hopefully it'll make a little more sense. So what I'm going to say, for j in a range, start to end, and so end is exclusive, so I don't have to worry about that. I'm going to say that if a of j is less than the pivot, I'm going to swap a j with ai, and I'm going to increment I. And then at the very end, so what this is basically doing is if I remove this, or if I remove this, in this case, we bubble through. We choose 5 as our pivot, and now we start at the very first number. In this number, our 7 is not less than 5, so it doesn't qualify for this if statement. So we're not gonna run it, and we're gonna go on to the next iteration. Our 4 is less than our 5, so we're gonna flip. Our I is right now on the 7. I'll put that here. Our I is on index 0, and so we're gonna flip our 4 with our 7. And so we're gonna get something like this. And so now we know that our 4 is definitely less than our 5, which is our pivot, and then we can increment our I. So now our I index is gonna be here. And so now our I is gonna be at the 1. And so what this is gonna do is if we choose to swap again, we know that we're not gonna be swapping with the 4, we're gonna be swapping with the 7, because we know that 4 is already in the right place. So we can just leave that there as it is now. And so now we run the 7 again, it's not less than 5, we go to 6, it's not less than 5, then we get to this 3, our 3 is less than 5, and so if you remember, our I is at the 1, is at index 1, so we're going to swap our 7 and 3, so now we're going to get 4 and 3, 6 and 7, and then we're going to have our 5 as our pivot. And so now, if we're going to increment our I also, because we swap and then we increment our I, so now our I is over here. And so in this case, we know that now, since we've bubbled through everything, we went through every number, and if our number was less than our pivot, we swapped it so that we know that we bubbled it over into a position where we know it's definitely less than the pivot. Now that our I is over here, we can just swap this I index with our last number, because if we do that, we can get 4, 3, 5, 6, 7, or not, no, not 6, 7, 7, 6. And so in this case, we know that this is our left half, this is our right half, and now all the numbers on the right are definitely greater, and all the numbers on our left are definitely smaller. And so hopefully that made sense. I'm going to code that in right here. I'm going to say A of I and A of high, or not high, end, is equal to A of end and A of I. And at the very end, I'm going to return I. And so this is where we can use our index, and we can say that if this is our array, if this is our final array after this one iteration, we return this index, we can say that if we go from index plus 1 to the very end, we're going to be running quicksort on this half. And if we go from start to our index minus 1, we're going to be running it on the left half. And so that's the idea of returning our index, so that we can run them on each half of the pivoted index. And so that is all we need to do for our quicksort array. And so I already have this index, this array right here. We can run that. I'll do python 3 quicksort.py. Oh, I'm not in the folder yet. If I run that again, start and end. Oh, okay. So I forgot the handle for this. One thing you can do is you can kind of use this quicksort method as a helper function. And so what I'll do first is I'll create an array called quicksort, and I'll run quicksort a 0 len a -1. And then I'll change the name of this function here to quicksort with underscore at the beginning. And so all this is doing is, if I save this, all this is doing is when we call quicksort here, we can just run this one array right here, and we're calling this quicksort function on our own, this helper function, and we're passing the parameters that we automatically want so that our the person who's using the function doesn't have to do that for themselves. It's kind of already done for them. And so once I do that, I get 3, 4, 5, 6, 7. So this is the right order for our array. I'll run another thing. I'll do 5, 4, 3, 2, 1. And so if I run that, we should get 1, 2, 3, 4, 5. And so all that's happening in this case is that when we're running these, we're using our last number as our pivot, and then we look through the rest of our array. We loop through the rest of our array, and if our number is smaller than our pivot, then we swap it with the I index at that point, because we know everything at the I index and everything before the I index is definitely smaller than the pivot, and so we can just swap it with the I index at that point, and just increment our I index, so that when we keep getting numbers that are smaller, we just keep swapping and we keep bubbling our numbers over. And so hopefully that makes sense. This is the gist of the quicksort function. Hopefully this helps you guys. If you guys want, definitely check out the uh, concept video that we have before. But this is the implementation, and thank you for watching. All right, see you guys next time.